Hi guys, welcome to the class. In this lecture, we are going to discuss about airport planning and designing. So here, what is meant by an airport and how this mean of transport is useful in these days. Here, introduction about the airport. Airport engineering is also encompasses the planning, designing, and construction of terminals, runways, and navigation aids to provide for passenger and also for freight services, which means an airport is a facility where passengers connect from ground transportation or whatever the transportation they are coming from, to another mean of transportation in air transportation. So in this airfield is an area where an aircraft can land and take off, which may not be equipped with any navigation aids or markings. So one system of transportation which tries to improve the accessibility through which there are less inaccessible areas. So this air transportation mainly involves the accessibility to the places where uh, we cannot move, we cannot access easily as possible by road or mean of water transportations. This air transportation is time reducing, and also it improves the journey quality, and this provides a easy passage from one place to another place. So it provides continuous connectivity over water and land, and also provide relief during main emergencies and better compared to other mean of transportations. So it also saves, previously we have said that it also saves the productivity of time and also the journey time we spend by other mean of transportations when compared to this air transportation. And it also increases the demand of specialized skill workforce. In this air transportation, it mainly helpful for tourism, generates foreign reserves, and also requires heavy funds during provision and maintenance, highly dependent on weather conditions compared to the other modes. It requires highly sophisticated machinery, and also it the purchase of equipments or airbuses with the flow of foreign exchange, and safety provisions are not adequate. Providing a support system during the flight is complicated. Specific demarcation of flight paths, and these main sources of development of air transportation in the early days. In 1918, the first international service between France and Spain. In the 1919, we have seen the London-Paris flight, and moving on, we have International Commission on Air Navigation was established in the year 1919, and in the same year, we have six European airlines formed in Hague, the International Air Traffic Association, to control the movement of air traffic and have a coordinated approach. And these are the yearly development of these aviations or air transportation facilities from 1918 to 1947, and so far 2006, the Airbus A328 made first flight, one of the biggest passenger aircraft. It can lift up to 800 persons at a time in the air. So in the 1911, the post was carried by air in India from Allahabad to Naini, and in 1912, flight between Delhi and Karachi. On 1927, civil aviation department was established. And what is the Airport Authority of India? The it means International Airport Authority of India, that is nothing but IAAA. I. So it controls over air navigation in India, constituted by an act of Parliament, uh, and it came into force on 1st April 1995, which formed by merging National Airport Authority and International Air Authority of India. The main functions of this Airport Authority of India, which controls and manages of Indian airspace extending beyond the territory limits, and it design, development and operation of domestic and international airports, construction of and management of facilities, and also the development of cargo ports and facilities, provision of passenger facilities and information systems, expansion and strengthening of operating area, provision of visual aids, and provision of communication and navigational aids, which is nothing but the radar system, the development of radar system from mutual understanding between the moving of these airways from one location to the another location by crossing of the borders. There is an allied act of the parliament. So, and also a radar system has been arranged for the communication and navigational purposes of the movement of these airways. So, the major components of the aircraft are these airplane parts. These are the airplane parts and functions of those airplane parts. Here you can see the here you can see this is the cockpit area where the command and control has been done by those who are charging those plane for moving, and this is the fuselage where it holds things together which carry payload, and these are wings which generate lift for this plane, and this is the turbine engine which that generates the thrust for lifting up of these airplane, and these are the winglets which decrease the drag, which decrease the opposite uh, the air pressure uh, putting onwards to this plane can be decreased by those these winglets. And here we can see these are the horizontal stabilizers which controls pitch movement, and also this is the vertical stabilizer which controls this is the radar which changes the direction, and this is the elevator which change the pitch, and flaps, these are the flaps. We increase the lift and drag for the plane, and these are the aileron, and they change the roll. These are the spoilers. They change lift and drag and roll. These are the slats, increase lift. So these are the major component parts of this airplane. What are the? This is the wingspan. This is the front view of this aircraft. Wheel, wheel thread or track. This is the distance between the inner to the inner of the wheel is wheel thread or track length. These are the wingspan. This is the front view of the aircraft, and this is the side view of the aircraft. Here, this is the nose gear, and these are the main gears. This is the length between the nose gear to the main gear is of wheelbase. So maximum height of the plane. This is the length of the plane. Aircraft components here, the plan and the side view, the path of nose gear and the path of main gear, the maximum turning radius. These are There are different types of engines and different types of propulsions based upon the engine we used. So the engine type and propulsion, atmospheric propulsion and trans-atmospheric propulsion. The propulsion may be through any type of engine: piston engine, jet engine, which means a turbo, turbo propulsion or ramjet, or a rocket engine. So, based upon the different types of engines we are using, the different types of propulsions we are gaining for these aircrafts, the propulsion may be through any type of engine, the piston engine or jet engine, whatever it may be. The piston, which we use for the piston engine, most conventional form fuel is converted to mechanical or electrical energy. The jet engines, these have a capacity to provide a jet with highest thrust, which is used for the movement of this aircraft. So different types of jet engines exist. In case of turbo jet, known as turbo propulsion, which is used here, not simple thrust is used. Instead, huge amount of air is sucked and is transformed into jet. The rocket engines used in trans-atmospheric propulsion systems, which has speed power increases from piston to rockets. The types of propulsions here, based on the propulsion, based on the engine we used, the speed limit, the propulsions can be varied. So when we use a piston engine, it can attain a maximum speed up to 750 kilometer per hour to minimum of 250. Minimum can be controlled by the uh, operating persons in the cockpit. So uh, by using the ramjet engine, we get by using ramjet engines, we get a propulsion speed of we get a maximum speed of 1280 to 2400 kilometer per hour. So by using rocket engines, we can attain a propulsion speed of 4600 kilometer per hour. The operative altitude of aircraft depends upon types of engine and the propulsion power available to the aircraft. So while using piston engines, the altitude of these aircraft can be observed low, and while using these turbo propulsions, turbojet or turbo propulsions, we can see altitude of low to high altitudes while using ramjets, using in missiles, which is used in missiles at middle altitudes where other type of movements are less. So while using these rocket jets, we can see these operative altitude outside the atmosphere. Based on the size of aircraft, the one of the most important aspect of the aircraft is the size of this aircraft. Here, not just the size of the main body, but the size of overall wing space is considered very important by the FFA guidelines. Aircraft wing space is considered, but not main body, for classifying the airport. So while designing of this airport, we have to consider the overall wing space, which is a very important thing while constructing of these uh, airports. So, and also the main body, the size of the main body is also to be considered while classifying the airports. It is important to look at different aspects of the size. uh, the size of the aircraft involves fuselage length from nose of the aircraft to the tail of the aircraft. This is the fuselage area, which composes the fuel which is to be transported along the aircraft, which is used along the path. At the same time, it also encompasses the payload, and that is the passengers and the freight that will also be placed within the fuselage length, the height and width at the tail. Since additional wings are provided at a tail in lateral vertical directions, gear thread distance between the main gears to the nose gear, uh, the wheel base, the distance between the nose gear, pilot location where the front wheel can be seen, and the main gear at wings connection can be seen. The distance between those nose gear and the main gear is known as wheel base. The gear thread is nothing but the distance between these two, the distance between the inner to inner distance between the main gears. So, wingspan measured at the location of wings to the furthest ends of wings. The wingspan decides the width of the taxiway. Depends upon the span of the wings we provided for the aircraft. The width of the taxiway can be decided the clearance between the two parallel traffic ways. For if one aircraft is landing, another is on takeoff on the runway, so the distance, the clearance distance between these two parallel traffic ways, two apron ways for the landing and takeoff of these aircrafts can be considered uh, with the wingspan. So the size of apron and hangar and also the width of hangar gate can be decided by the wingspan. The major characteristics of these aircraft are the length of aircraft decides the winding of taxiway on curves, the sizes of apron and hangar, the height of aircraft or empennage height, the height of the aircraft. It decides the height of the hangar gate, the gear thread and wheelbase, minimum turning radius of the aircraft. Here, the gear thread and the wheelbase can decide the turning movement of the turning radius of the aircraft in air. So the pavement thickness, design, materials, etc. depends on the weight and wheel distribution of the aircraft. Here, if the length of the aircraft is heavy, the length of the aircraft is high, and the wingspan is more, the pavement thickness can be depends on the weight of the aircraft and also the wheel distribution of this aircraft. So different types of weights, the maximum gross takeoff weight, the total amount of weight when it is taking off from the runway, nothing but the maximum gross takeoff. So while taking off, while moving at a speed of 200 kilometers per hour, 300 kilometers per hour, so the maximum gross takeoff weight can be known, can be calculated by laying up of these pavement thicknesses. So the maximum standard landing weight, while landing, the fuel consumed during the transport will be deducted from the takeoff weight. So while taking off, the wheel loads, the impact of the wheel loads and the impact of these aircraft load can be reduced with the fuel amount. Overall weight of the aircraft can be added with the amount of fuel in it, and the load and impact produced on the pavement can be calculated. While uh, while landing while landing the weight can be reduced due to the fuel consumed during the transport can be reduced landing while landing. So operating empty weight, operating at zero payload. What is meant by payload? The load for which revenues are generated, passengers plus freight. Freight is nothing but the material, the load, the dead load of the except the passengers, the carrying load can be considered. So the load for which revenues are generated is known as the payload. The zero fuel weight aircraft reaching destination and fuel is getting empty. Note, in this zero fuel weight, the maximum is taken considering biggest aircraft allowed at the airport. If the biggest aircraft is allowed at the airport, the uh, the fuel weight can also be came to considerations. While considering the zero fuel weight, the maximum is taken considering the biggest aircraft allowed at that airport. So field configuration defines how the weight will be transferred to the bottom. How the weight will be transferred to the bottom. More the number of wheels, lesser the stress. Hence, the less thickness is enough. If the more number of wheels, if we provide a number of wheels, the more number of wheels for the aircraft, the stress developed, the stress produced uh, is less when there are more number of wheels. So the thickness is uh, less, the thickness is less can be considered enough for the major number of wheels for the locomotive, for the for the aircraft is provided. Different wheel combinations available based on the size of the aircraft. Single tandem, dual tandem, and multi-axial tandems are used based on the size and weight of the aircraft. Some wheel configurations are shown in the next slide. Here you can see the single wheel main gear with single wheel nose gear. Here, here, this is the main gear. The distance between the two lower end wheels is nothing but the main gear. And also the single wheel nose gear. Here, the distance between the uh, uh, front wheel to the back wheel is nothing but nose gear. Here, single wheel main gear and with a dual wheel nose gear, and here dual wheel main gear with the single wheel nose gear. These are the wheel arrangements for the aircraft. Different wheel arrangements we can observe in the aircraft. Here, if the load, if the freight is heavy, the payload is heavy, so these wheel arrangements can be considered: two dual wheels in the tandem, two tandem main gear, and with a dual wheel nose gear. Here you can observe the another dual wheel main gear with dual wheel nose gear, and here two dual wheels in tandem. Here you can observe a pair of two wheel arrangements, a tandem main gear with the dual nose gear. And here two dual wheels in tandem main gear, two dual wheels in tandem body gear with dual wheel nose gear being this can be seen in Boeing uh, 747 aircraft, Boeing, which is a used for transportation of American president. The minimum turning radius. While making a turn, the nose gear is steered and hence it makes an angle with the axis of main gear called angle of rotation. The point of intersection of the axis of main gear and line through axis of steered nose gear is called the point of rotation. The max angle varies between 50 to 60 degrees. 50 to 60 degree maximum angle varies between the uh, nose gear and main gear. So the line joining the center of rotation and the tip of farthest wing of aircraft is known as minimum turning radius. The amount depends on size of the aircraft. Here, the maximum angle, the amount of angle, the angle of rotation depends on the size of the aircraft. Size of the aircraft. The minimum circling radius. Related to the movement of aircraft within the air, radius in space required for the aircraft to take a smooth turn. It depends upon the size of the aircraft, the power and type of propulsion system in the aircraft, the wingspan, and the distance between uh, the distance between the nose to the main gear. These are all come to consideration while circling of the aircraft. So the circling radius depends upon the size and the power of propulsion system we have arranged, and also air traffic volume, and also taking consider of weather conditions. It is the total radius which is provided at the top of the airport in which the aircraft will be circling if it is not allowed to land. So, when an aircraft is arriving to the landing point or the airport authorities do not allow that aircraft to uh, land in their premises, or is there any taking off aircraft is seen. So they have to take a total circling around this airport to stop the collision of these landing and taking off aircrafts. If there is a one pathway, one apron, one landing and taking off pathway has been arranged. So while landing, an aircraft uh, cannot be permitted while taking off another aircraft. So in these such conditions, they have to turn the aircraft around those airport. It is the total radius which is provided at the top of the airport in which the aircraft will be circling if it is not allowed to land. So speed of the aircraft in air relative to medium. Indicated by the instrument on board, 2% lower than actual true speed. The reason is it is relative speed. What is true to get the correct value of the speed? 2% is reduced for resistance in air. While traveling in the mid-air, the speed of the aircraft can be reduced by 2% due to the resistance in air. Resistance in air. Capacity of aircraft. Number of passengers and amount of cargo it can handle and dependent on size, propulsive power of aircraft, speed of the aircraft. Noise. This is the big problem if nearer to the developed areas. The major sources of the noises are the engine, machinery, more during landing, and primary jet, more during takeoff. The machinery, the aircraft makes much noise during the landing stage, and also a primary jet while take off. Here, the disturbances are more during takeoff. Since the inception of jet engines, the noise has been reduced to a great extent. Great extent. The vortices at tail end. The vortices form at tail when moving at high speed have a tendency to break tail if they are heavy, and eddies are formed. Eddies are nothing but the whirlpools which are formed in mid-air. The air can be rotated in circular ways. These eddies formed at due to the heavy winds flowing towards the aircraft, the tendency to break the tail if the eddies are formed. So vortices are made of two counter-rotating cylindrical masses of air extending along the path. Uh, these are formed near tail ends of wings or tail end of the aircraft. The velocity of wind in these vortices will be very high, very high. Jet blast. This aspect belongs to aircrafts having jet engines. This is the blast that comes out of jet engine at the rear of aircraft to provide a force for movement. If we consider the case where aircraft is standing and jet blast is coming from backside, it is so hot and creates severe conditions. The severity depends on the height of the tailpipe and angle of this tailpipe. Hence, the blast fences are needed to control the damage to the pavements. The blast fences are needed to control the damage to the pavements, while aircrafts which are having jet engines,
Then this is the blast that comes out of the jet engine at the rear of the aircraft to provide a force for the movement of the aircraft. To move the aircraft, these just jet blasts can be seen the aircraft which are having jet engines. So while providing a force for the uh, movement of the aircraft, these jet blasts can be seen and they can damage the pavements. Why? To control the damage of the pavements, the blast fences are needed. Fuel spillage. Spilling of fuel occurs when the engine is shut down or losing speed. It is spilled fuel from the engine or other locations into the aircraft. This may cause the speed when it is moving on runways or taxiways or aprons. The influencing characteristics of aircraft on design of aircraft. The engine type and propulsions. The major characteristics for aircraft on design of airport. So depends upon the aircraft, we have to design the airport. What are the conditions? What are the characteristics of the aircraft that uh, helps in designing of airport? First one is engine type and the propulsion, the type of propulsion. So whether it may be of ramjet or any type of jet engines. Uh, so the type of the propulsions, rockets. So depends upon the engine type and propulsions. The design of airport can be considered, and also the size. If it is having the higher size and the wingspan is high, so depend upon the size, the apron, the length between the two lanes can be varied. So the design of the airport can be disturbed by the size and aircraft weight and wheel configuration. The minimum turning radius and minimum circling radius. The speed capacity of the aircraft, the noise produced by the engines or the aircraft, the vortices at tail ends, the jet blast, and also fuel spillage. These are the characteristics. These are the characteristics of the aircraft uh, which is used to design an airport. To design an airport, engine type and propulsions, size of the aircraft, speed, the length of the runway. If more speed or longer runway can be considered. If the engine is having a heavy speed, the length depends upon the uh, aircraft. The length of the runway can be constructed. The length of the can be runway can be seen, whether the short runway or a longer runway. The weight more if bigger propulsion systems. If we are using a heavy propulsion systems, the weight of the uh, aircraft can be heavy, and the carrying capacity, it depends on size. It depends on propulsion systems, type of propulsion systems we use, the noise capacity, the noise can be heard so far. So the circling radius, while using high power and speed aircrafts have high radius. The range, a distance it can move without refueling. If the maximum range can be covered by an aircraft, the maximum distance it can move without refueling. The maintenance facilities, ballast pads, which are required for jet propulsions while controlling the damage of pavements. The size of aircraft influences load carrying capacity, other facilities like apron, terminal areas, and the bigger the size, larger are facilities to be provided at airport terminal building. Wingspan will increase with size. It has effect on taxiway width, separation between traffic lanes, size of gate, apron size, width of hangar, etc. Length, the widening of taxiway on curves, apron, hangars, width of exitways. Height, further influences height of hangar gate. Wheelbase, gate rate also changes. Aircraft wheel configuration, thickness of runway, taxiway, apron, distribution of load to the ground, and turning difficult for more weight in case of sharp curves. In case of sharp curves, stability depends on the support system provided and also depends on wheel configuration. Minimum turning radius, the radius of taxiways. Taxiway is the connecting pavement which is provided between the runways and aprons. Minimum circling radius. It defines the minimum distance between two nearby airports. For larger aircrafts, it will be in kilometers, hence more distance is required between two airports. Adjustments of timings of landing and takeoff, airport capacity decrease with increased air circle time. Airport capacity can be decreased with increased air circle time. Zoning laws related to height of obstructions. So speed, it reduces in aircraft. The speed is the measure mean of in air transportations. Speed, it reduces the journey time from one location to another location. Increase in frequency of operations, the number of trips, the number of carrying, the number of persons that carry from one place to another place far away uh, can be increased in frequency of operations. Improving and broadening the air network systems, the capacity, the processing terminals, the passengers and baggage handling facilities, the cargo processing, the size of apron, and special equipments will be seen if the capacity has been increased. What is it? Vertical vertices at tail ends. These are most dangerous things for an aircraft to happen. So if the eddies which are formed at the vertices can damage the tail ends of the aircraft. The stresses at fuselage and other joints, pressure under wings, producing lifts and drags. These are the eddies which formed on the vertices can damage the aircraft in the mid-air. The jet blast, inconvenience to passengers, may do harm to airport runways and other components of the airport. The fuel spillage, the which is badly affects bitumen pavements. To control this damage, uh, the the airport authorities may do harm to airport runways and other components of airports. The fuel slippage badly affects bitumen pavements, causes slip of wheels on the pavements on the runways. The selection of site for airport, air traffic potential, magnitude of passengers and freight traffic expected to travel from one location or one point of location to the other point, the air traffic potential, and also adequate access from these major cities to other cities, the sufficient airspace, circling radius between uh, landing and takeoff of the aircraft can be happen. So the circling radius of the uh, aircraft which can't be allowed at that particular airport can take these circling radius should be taken care. The sufficient land, various facilities, the terminal buildings, security systems uh, must be built around the airport. So the sufficient land should be required for building up of an uh, airport. So these airports which we are constructing at the site must have accessibility to major resources within the city hall, so it can be easily chosen for the transport from one place to the another place, and the number of locations which is traveling, which it is traveling. The airport which is maintaining the aircrafts can travel so long and so businessable areas from one location to another locations easily. So adequate access can be seen in the when the airport is in the middle of the city. So the atmospheric and meteorological conditions, the availability of land for expansion, if the population at that particular city where the airport has been constructed is developed, and the city has been uh, is grateful for any businesses, so the availability for expansion for further expansions can be can also be observed while constructing of this airport. So availabilities of so many utilities for the selection of the site, the development of surrounding area, the ground accessibility must be seen near the site selection of the airport, the presence of other airports, the regional plan, the soil characteristics, surrounding obstructions, use of airport, the atmospheric and meteorological conditions, visibility. So while selecting of the site, the visible factor of uh, the site for that atmospherical and meteorological conditions can be seen. Fog, smoke, haze, the affected by the wind, development of area, industrial area. So it may have these foggy uh, areas if and also causes reduction in frequency and hence incapacity handling. Wind, direction and intensity, associated topographical features, hills, valleys, windward side, so locating development with respect to the site of airport. Availability of land for expansion, future prediction of air traffic, land for parking vehicles, providing facilities, land cost at later stage, availability of land at later stage, availability of utilities, water, power, sewerage, communications, like that. So the development of surrounding area, the residential or sensitive area, the industrial development, height of development, zoning laws, noise pollutions, movement of air pollution, birds, and hits at engines. So the area, the site which we are selecting for uh, construction of an airport, these are the conditions we must go through while selection of the site. The economy of construction, alternative sites to be examined, the availability of local construction materials, and terrain even or not, the landscape which is even or not, the problematic areas, waterlogging areas, reclaimed areas, or water filled areas, uh, the depends upon the uh, terrain conditions, depends upon the availability of the construction materials, and also the alternative sites to be examined while constructing of these airports, and also waterlogging areas, if the landscape is not even whether these are all the conditions which plays a major role while constructing, uh, depends upon the economy of constructing of these aircraft. So the ground accessibility, travel time in air versus on the ground, easily approachable using all modes of mean of transportations to get near to the airport, the proximity to areas of trip generations and facilities for private vehicle users, efficient transport system. So the ground accessibility to reach this airport within the city or outward the city. So the travel time can be seen from major areas to the airport, and also the easily approachable using all modes of traffic. All modes of traffic can be seen. The proximity to areas of trip generations. So the airport can generate the revenue for trip generations. The presence of the other airport, traffic volume and circling radius, the types of aircrafts in different airports, the type of operating facilities. Separation distance between the radii may cause accidents, a reduction in capacity. The characteristics of soil, where the site selections can be done, the characteristics of the soil to be noted. The strength of soil uh, in the subgrade and drainage of the soil. So if the water we poured on the soil can be percolated easily, so uh, there are the voids present in the uh, subgrade of the soil. So at sewerage lines, the drainage of the soil can be cleanly observed while construction of airport. The level of water table and its impact, the subsoil drainage effects. Valley side may have flooding. Soil with good amount of pervious material like sand or gravel is considered good. Use of airport, civil law for military, adaptability for other uses during emergencies, surrounding area obstructions, clear airspace for takeoff and landing can be if around the airport there are the heavy buildings or the heavy industrial regions have been surrounded these airports, so the clouds, the fog, the amount of uh, wind, the amount of bad foggy like things which are discharged into the air can make inaccessible for the flight, for the aircraft to land or take off if the airport is surrounded by heavy construction, heavy buildings. So high-rise buildings are not allowed in the regions of these airports, and high trees are cleared off. The zoning laws are made to take care these factors. The major factors affecting the size of airport. The size of airport defined by the space for operators, controlling systems, facilities, manpower, etc. These are controlled by peak aircraft traffic, aircraft characteristics, and elevation of airport size above mean sea level. The density and air pressure reduces, affects runway requirements, lift, drag, etc. So meteorological conditions like wind and temperature and performance characteristics of aircraft, volume of air, traffic, peak hour volume, size of aircraft, nature of the air traffic, runways, taxiways, etc. Thank you and see you in the next class.